Have you ever looked up at the night sky and just felt small? Well, today, we're going to find out just how small. We're about to go on a journey to the very edge of everything we know, on a quest to really understand the true size of our universe. And it all starts right here, on a tiny, familiar blue dot.
This is it. This is Earth, our home. And it's so much more than just a planet. It's the only stage our species has ever known. Think about it. Every single moment of human history, every person, every story, played out right here. This is our starting line.
All right, so to really grasp our place in the cosmos, we have to leave the nest. We've got to step outside. So let's start our journey by leaving Earth behind and aiming for our closest celestial companion. First stop, the Moon. It's just hanging up there in our night sky, this familiar beacon, at an average distance of about 384,000 kilometers. Now that might seem like just a number, but let's try to make that feel real. To put that into perspective, just imagine hopping in your car and driving to the Moon. Even if you were going full speed, no traffic, no stopping for gas, it would take you over 5 months to get there. And this is just the first step on our journey. The scale is already getting pretty wild. Okay, now let's push deeper into our solar system. The distances from here on out are going to get so extreme that our little car trip to the Moon is going to feel like a walk in the park. Our next big milestone is the star of our show, literally, the Sun. It's about 150 million kilometers away. This distance is so fundamental to us that astronomers actually call it 1 astronomical unit, or AU. It's basically the standard measuring stick for our solar system. So how long would it take to travel that 1 AU? Well, if you were on a commercial flight, you'd be in your seat for 19 years. 19! That's the kind of void that separates us from the very star that gives us life. Now this is a really cool way to visualize it. Let's use the fastest thing we know of, light. Light from the sun reaches us here on Earth in just over 8 minutes. But for that same light to get all the way out to Neptune, at the edge of our solar system, it has to travel for over 4 hours. We can't travel at the speed of light, of course, but we have sent a piece of ourselves out into that great unknown. And this is it, Voyager 1. Launched way back in 1977, it's this incredible testament to human curiosity. A silent ambassador just carrying the story of our world out into the void. As of right now, Voyager 1 has traveled over 22 billion kilometers from home. Let that sink in. That makes it the most distant human-made object in existence. It has actually crossed the boundary of our sun's influence and is now drifting through interstellar space, the space between the stars. But before it left, Voyager turned its camera back for one last look. From 6 billion kilometers away, Earth was just a single pixel, a tiny, faint dot. This image, the pale blue dot, is this profound reminder of our isolation and our shared responsibility for this one fragile home. Now that we've toured our solar system, it's time to venture even further, to the stars. But at this new scale, using kilometers or even astronomical units is like trying to measure an ocean with a teaspoon. We need a much, much bigger measuring stick. And that new measuring stick is the light year. Now don't let the name fool you, it's not a measure of time, it's a measure of distance. And it's the nearly 9.5 trillion kilometers that a single beam of light travels in 1 year. And this slide, wow, it just perfectly captures the sheer emptiness of interstellar space. Our closest stellar neighbor, Alpha Centauri, is 4.4 light-years away. To put that in perspective, our fastest probe, that Voyager 1 we talked about, would take over 70,000 years to get there. The stars may look close, but they are just unimaginably far. So, now that we've kind of wrapped our heads around the vastness between stars, let's zoom out again. Let's see the colossal structure that they all belong to. Our home galaxy, the Milky Way. Our galaxy is this sprawling, spiral city of stars. It's 100,000 light-years from one end to the other. It's home to hundreds of billions of suns. And our entire solar system, everything we've seen so far, is just an insignificant little speck inside of it.
So you have to wonder, how much of our own galaxy even knows we're here? Well, all of our radio signals, every TV show, every song has created this radio bubble that's only about 200 light-years across. So beyond that tiny bubble, we are utterly silent. To over 99.99% of the Milky Way, it's as if humanity never existed.
But guess what? The journey isn't over. Our massive galaxy isn't alone. It's just one node in an even grander structure, this vast network of galaxies that astronomers call the cosmic web. Think of it like our cosmic address. We live in the Milky Way galaxy. That galaxy is part of a small cluster of galaxies called the local group. That group is part of the much larger Virgo supercluster, which in turn is just one arm of the immense Laniakea supercluster. And here, the scale it explodes. Our local group is about 10 million light-years across. The Virgo supercluster spans 110 million light-years. And our home supercluster, Laniakea, stretches for a mind-shattering 500 million light-years.
You know, the name Laniakea actually comes from Hawaiian, and it means immense heaven. And that's just a perfect name for a structure that contains the mass of 100 million billion suns, all held together by gravity.
We've now reached the final leg of our journey. We are going to zoom out as far as humanity can possibly see, all the way to the very edge of the observable universe.
This is it, the edge of everything we can see. The observable universe is 93 billion light-years across. But hold on, here's a puzzle. If the universe is only 13.8 billion years old, how could it be so big? The answer is that the universe isn't just expanding into empty space. Space itself is stretching. The very fabric of reality has been expanding since the Big Bang, carrying the oldest galaxies away from us and making the universe much larger than its age might suggest.
And this brings us to the final, really humbling realization. We can only see the part of the universe whose light has had enough time to reach us. Beyond that horizon, the universe continues, but it's expanding away from us faster than the speed of light. So we are left with the ultimate question: what lies beyond? The honest answer is, we don't know, and we may never know.